Welcome to Get Your FRQ On. This question is from the 2004 B exam. It's question 1, and it is calculator active. In the question stem, we have a function y equals the square root of x minus 1, and a region R defined to be the area bounded by the function, the x-axis, and the line x equals 10. In part A of the question, we are asked to find the area of the region R. This is a calculator active question, so as long as we can set up the integral correctly and express it correctly, then the calculator can do that work for us. So we need the area of R, that would be given by the integral from 1 to 10, of the square root of x minus 1 dx, and if we use the calculator to do that, we get 18. In part B of the question, we are asked to find the volume when the region R is revolved around the line y equals 3. And one thing to understand about this is the graph of y equals the square root of x minus 1 is less than or equal to 3 for all values of x between 1 and 10. And since we're revolving around a horizontal line, y equals 3, we will be integrating with respect to x. And there is going to be some area we have to sort of carve out of this solid. So we're going to use the washer method. The furthest boundary away from the line y equals 3 is going to be the x-axis. So our big radius is going to be 3. Our little radius is going to be 3 minus the function square root of x minus 1. That's the boundary that's closest to the horizontal line y equals 3. And from here, we set up an appropriate integral using the washer method, the integral pi times the integral from 1 to 10 of my big radius function squared, so 3 squared minus my little radius function squared dx. Again, this is a calculator active question. There's no need to try to simplify this. Just make sure you understand how to enter it into your calculator correctly and let your calculator do the work. The volume is 212.058 cubic units. In part C of the question, we are asked to find the volume when R is revolved around the vertical line, x equals 10. Now, because we're revolving around a vertical line, we're going to have to integrate with respect to y. I guess you could use the shell method, but that's not tested on the AP/AB exam, so probably not. So we're going to have to rewrite our functions in terms of y. So if we have y equals the square root of x minus 1, and I solve that for x, I get x equals y squared plus 1. But then my bounds also change. Instead of integrating from 1 to 10, I have to integrate from the corresponding y values, which in this case would be 0 and 3. But it's strictly disk method here. There's nothing carved out of this when we revolve around the line x equals 10. So I use the disk method here. The volume is found by pi times the integral from 0 to 3 of 10 minus y squared plus 1 squared dy. And again, this is a calculator active question, so let your calculator do this work. The volume when R is revolved around the line x equals 10 is 407.150.